right, we're going to talk about the last section in exponents here as 8th graders. We are going to use the division property. This is the last little trick you're going to have to know and to be able to distinguish. And let's just try to recap all the little tricks we've had. So we've had the negative exponent was the first thing we were exposed to. We were also exposed to zero exponents. What's another one?
No, we did yesterday.
The multiplication property, that's where you add up the exponents. Multiplication, I can do this. Multiplication property. Okay, we did a power to a power. Did we do anything else? I don't think we're missing anything. Now we're going to do division properties. So all these properties, I'm expecting you to be able to identify and utilize to simplify exponent expressions. So that's 1, 2, 3, 4, 5 different properties. Now, I'm going to show you. I'm going to scaffold your knowledge.
So then we get to move the x2 and make that negative move back to the top?
No,
No?
kinda. Maybe you're thinking right. What I would do here, watch. Shh. What I would do, I could, let's go back to 7th grade when we expanded these. This is called the expansion. Write it down in your notes. This is going to help you formulate the property. Well, x cubed is really x times x times x. Over x squared is really x times x. Now what happens? Those two can cancel. Those two can cancel. And I'm left with just x.
Yeah.
Now I want you to try to identify what's the property. What's the little rule that I just did? So try to formulate a pattern that you notice to this power and with these two powers. So the 3 and 2. Now I want you to kind of have that in the back of your mind. We're going to test your thoughts. A to the 4th b cubed over ab squared. If you developed a little hypothesis, I want you to try to think what you would simplify that into yourself. Now I'm going to expand it out. This a to the 4th is 4 a's, a times a times a times a. B cubed is 3 b's times b times b times b. All over a is just a. B squared is 2 b's. Cancel out common factors. That's common. That's common. And another b is common. So we have a to the 1, 2, 3, b just by itself. Just one b. So I want you for a moment to share what you think the property is. So what you should have noticed, the relationship between a 4, this is like a 1, I subtract them to get the 3. This is b cubed and a b squared. I subtract the 3 and 2 and I get that exponent of 1. That leads us, that'll always be the case, which leads us to the division property of exponents. Might technically be called the quotient property. Maybe I'm going to look this up. Write it down though.
That's what I was going to ask you.
All right, a to the n over a to the m is equal to a to the n minus m. This is called the division property of exponents. So the division property of exponents allows us, if we're given a quotient, a division, a fraction, that we can just, as long as they're the same base, notice here the a and the a, they're same bases, I can just subtract their exponents. So a to the n over a to the m would be a to the n minus m. Just subtract the exponents. I don't know if you want to write that down, that all you do is subtract exponents. Okay, we're going to apply these skills. So I'm just going to make some for you to write in your notes, and then we're going to practice some more. So if I had a to the 5th over a squared, that would equal, write it in your notes, a to the 5 minus 2, which is a cubed. Okay? And again, it does get a little more difficult because you're going to have to start applying all the properties that I've shown you so far. Let's try it. A to the 16th, b squared over, now we're going to jump right to the difficult one, over a to the 16th, b to the 5th. I want to try to simplify that. I would turn this into a to the 16 minus 16, b to the 2 minus 5, a to the 0, b to the negative 3. A to the 0 kind of cancels out because it's 1. That turns into 1 over b cubed final answer. That's about as difficult as it's going to get. Remember, when we convert this to the bottom, it turns that exponent positive. So, the first thing I'm going to do here, with this negative examples, I have x to the negative 2, y cubed, over x cubed y to the 4. This is going to turn into x to the negative 2 minus 3, y to the 3 minus 4, which is x to the negative 5, y to the negative 1. They're both negative. That turns into 1 over x to the 5th, y to the 1st, which is just y. All right, we're going to do another one. I want you to simplify this exponential expression.
Doing the same thing.
Here's an example that a lot of students mess up on because they think that it's gonna be like a negative 1, this first x term, but it is not. This turns into x to the 2 minus a negative 3, y to the 4 minus 4. When you minus a negative, you're adding x to the 2 plus 3, y to the 0. Y to the 0 cancels out, and you are left with x to the 5th all by its own. Okay? All right, we're going to do another example. I actually need you guys to do something quick. Okay? I know, but now I need you to do something else. This is called a quotient to a power. And when we do a quotient to a power, no, Zach's probably right, because what you should be able to take what I've taught you so far and know how to extend that.
Is that it?
Cancel. X to the 4. Get rid of that, right?
Oh, so is it x equals x? Yeah.
Yeah.
Hey, I had that.
got this. Yeah, you do. You just forget what the y's in the beginning, though.
You could.
You could. Yeah, that's what I did. I forgot what the y.
In the beginning.
Yeah.
minus
Okay.
1 by 1.
All right, we need coefficients examples. Okay, we're going to deal with some coefficient examples next. My little strategy, and there's multiple ways you can do this, I'm just sharing my preference, okay? I like to simplify the variables, then simplify the fractions. What I mean is you might have something like this, 10x squared y cubed z over 5x y to the 4th z. You might have something like that. And it's going to tell you to simplify that exponential expression. What I would do, I would just kind of not worry about my coefficients, okay, personally. And I deal with the exponents that I have. So I have x to the 2 minus 1, y to the 3 minus 4, z to the 0, 1 minus 1. X, y to the negative 1, z to the 0, cancels out. And we get x over y. Okay? Because y to the negative 1, the y would cancel. The y would go down. Now I have my 10 over 5 that I can just, well, what's 10 over 5? 2. 10 over 5 is just 2, so I just kind of throw that out. Usually it's actually 2x over y, because that's 2 over 1. Okay? Okay. So that's not a mixed number, that's just a whole number.
It's just complicated.
Oh, yeah, it's like that. Oh, the 2xy, like that, like the 2 and the xy. I think MCAs are going to have it that way. Okay, you're going to do one in your notes. Let's do 9a to the 4th, b to the 5th, c to the 5th, all over 6a b to the 4th. And I want you to simplify this exponential expression. Okay, so the first thing I'm going to do is, maybe I gave you the wrong strategy at first because I see a lot of kids are writing it my first way, and I don't think the MCAs would ever allow you to do that. What I mean by that is you are writing like 9/6 and then a cubed b c to the 5th. I don't really want you to do that. I want you to write that as, well, first off, both of them share a factor of 3. I want you to write it as 3a cubed b c to the 5th all over 2. That's how I want you to write it. I want you to write it like this because the MCAs will be written this way. Okay? All right, I think I have given you, let me just double check. I think I've given you plenty of examples, but nope, we're going to do more power, quotient to a power. I want you to simplify this. I want you to simplify this quotient. And I want you to just try to, I haven't given you the actual property, so there is an actual property for this. I see a couple students already have it right. The parentheses should tell you want to distribute. And when you distribute, you want to distribute that exponent. Distributing means multiply. Yes. Awesome, you guys are looking great. Okay, I think we're good. I think that is about all you need to learn for